In today's video, we're building the ultimate bang for your buck custom PC designed specifically for Linux. I'll walk you through the part selection as I construct the system. After installing Arch Linux, we'll put it to the test with some baseline performance benchmarks for productivity, content creation, and of course, gaming. This is where your open source journey starts. Welcome to Lifting Linux. Hey guys, I'm CJ, and this is what I believe to be the best bang for your buck custom PC for Linux. That's a bold claim and obviously very subjective, but stick with me. I'll break down exactly why I think it holds up. The system isn't just another PC build, it's designed specifically for testing and showcasing Linux distributions on real hardware. Instead of spinning up virtual machines, I'll be running distros exactly how most users would on a physical desktop. That means real-world performance, real compatibility insights, and a proper look at how different Linux distros handle daily workloads. To make that happen, I needed a build that balances performance, compatibility, and affordability. And today, I'll walk you through the parts I chose, why I picked them, and how they all came together to create an ideal Linux test system. Just a quick heads up, I recently tore my Achilles, so setting up fancy B-roll shots isn't really an option this time. Production quality might take a slight hit for a little bit, but the content should still be rock solid. So let's jump in, break down the build, and see what this system can do. To start, let's talk about the criteria I used when putting this build together. Since this PC is meant to test and showcase Linux distributions, I had to be strategic about the hardware selection. The goal was to strike the perfect balance between compatibility, availability, and affordability without sacrificing performance. First, I wanted hardware that would work with as many Linux distributions as possible right out of the box. That meant avoiding bleeding edge components that might still have shaky driver support. Instead of going with the latest hybrid architecture CPUs, I chose a Ryzen 5000 series processor, still powerful but far more stable for a Linux test system. I'll break down each component choice in detail as we go, but that was the first big factor in my decision making. The next priority was availability. Even though I wasn't going for the newest generation of hardware, I still wanted brand new off-the-shelf parts that anyone could still easily pick up from major retailers. The only exception is the case. Fractal sent me this one a while back as a review sample, but it's still widely available for purchase. Everything else I bought brand new over the past few weeks. And finally, budget was a big factor. I wanted to keep the total build cost under $1,000, which I easily managed at the time of purchase, but since then, tariffs has caused prices to spike on several of these parts. Now, I'm not here to talk politics, but it's definitely strange how tariffs that just went into effect a couple days ago are suddenly raising prices on products that have already been sitting in the US warehouses and retail shelves for weeks now. So while this build was well under $1,000 when I bought everything just within the past few weeks, today it's probably right on the edge of that price point. With all that in mind, let's go through the parts I chose and why they make sense for a Linux-focused system like this. First up, the CPU. For multiple reasons, I went with the Ryzen 7 5700X 3D, mainly for the price, performance, efficiency, and availability. A couple of weeks ago, I picked this up for just $180 at Micro Center, and it was selling for around $200 on Amazon and Newegg. But then, as soon as tariffs hit a few days ago, retailers jacked up the prices on their existing stock. Now it's sitting at about $250 at Micro Center and between $265 and $275 on Newegg and Amazon. Today, I'd probably go with the 5800X since you can still find it for under $200. But if you can get the 5700X 3D at a decent price, it's a great pick. It still tops the charts in a lot of gaming benchmarks, going toe-to-toe with CPUs that cost twice as much. For productivity, development, and content creation, you're still getting 8 cores and 16 threads and a solid 4.1 gigahertz clock speed, so it's a great all-arounder. But if gaming isn't your focus at all, then I'd actually recommend the 4.7 gigahertz 5800X or even the 12-core 5900X, which is still available for under $300. One of the reasons I stuck with this CPU generation on top of the smooth Linux support is because it let me save money on the platform too. I grabbed an MSI Pro B550M VC Wi-Fi micro ATX motherboard for under $100, nothing fancy, just what I needed. The cool thing is this board has a swappable M.2 Wi-Fi adapter, which means if I run into compatibility issues with older LTS distros that don't support its MediaTek adapter, I can just swap in a supported one pretty easily. For memory, I originally planned to use a 32GB kit of Corsair Vengeance DDR4 3200CL16, but I had a bit of a mix-up. I thought I had a 2x16 gig kit. Turns out it was a 2x8 gig kit, so I just ordered another matching kit on Amazon for next day delivery. Easy fix. If you're putting together a similar build, you've got options. 3200 CL16 for around 50 bucks or 3600 CL18 for about 60, depending on whether latency or bandwidth matters more for your workload. Storage-wise, I went with a 2TB Crucial P3 NVMe SSD. It's a great balance of price, speed, and capacity, plenty of space for apps, files, and even a decent game library. I picked it up for $117, which is solid for Gen 4 storage at this capacity. I'm also installing a second SP 2TB SSD, but that's just to hold my testing Steam library so I can wipe the boot drive with each distro and then not have to install the library every single time. Now the cooler. This one's on my elevated system viewers. A ton of people recommended the Thermalright Peerless Assassin 120 SE, so I figured I'd give it a shot. At first, I was ready to call y'all fools because my CPU was thermal throttling while just installing Steam games. Turns out, I was the fool. After 30 years of building PCs, I finally made the classic mistake, and yeah, I forgot to peel the protective sticker off the cold plate before mounting the cooler. Once I fixed that, yeah, y'all were absolutely right. The Peerless Assassin is pretty good. It keeps the 5700X 3D nice and cool for just $35. The only downsides, at high loads, it can have a bit of a high-pitched whine. Also, the tower isn't offset, so there can be memory clearance issues. As you can see, the fans sit directly on top of my low-profile DIMMs. The case I went with is the Fractal Design Pop Air Mini, a great micro ATX case for under $100. It comes with 3 quiet ARGB fans and a built-in RGB hub, so I don't have to deal with open RGB every time I install a new distro. If you want a deep dive, I already reviewed it over on Elevated Systems, but I actually picked this case for one very specific reason, which I'll get to in a minute. For power, I went with the Thermaltake Smart 700 watt, 60 bucks, nothing fancy, but it does the job. This newer W3 series has better safety features, reliability, and warranty, but I still wouldn't recommend it for a high-end power-hungry build. However, this mid-tier build has a max power demand of about 450 watts, so going overkill as I always do with a 700 watt version, it shouldn't have any problems. If you want an alternative, the EVGA 700BR is another great budget PSU. I've had one running for 6 or 7 years now, and it's still going strong in its third PC. Now, for the GPU, if this were a best bang for the buck Windows build, I'd probably be using my Intel Arc B580, and I still might swap it in later once Mesa gets full driver integration. But for Linux, I'm sticking with AMD. I don't want to mess around with proprietary NVIDIA drivers and all the issues they bring every time I install a new distro. AMD's Mesa-based open source drivers just work. If NVIDIA ever fully open sources their user space components, I'll probably reconsider, but for now, I went with the Radeon RX 7600 XT. It delivers awesome 1080p and solid 1440p gaming performance, good compute power thanks to its 16 gigabytes of VRAM. I went with the ASRock Challenger version because it's a true 2-slot card. It's compact at just 267 millimeters long, just slightly longer than the motherboard, so it fits in almost any build. and it only has 4 small white LEDs, which can be physically switched off, so no RGB vomit in my face all the time. I picked it up for $315, which is a great price for the performance it offers. Now, if GPU performance isn't a priority for your workloads, a 7600 non-XT would be a good option, and you can apply the money saved to a better CPU. Now, I mentioned earlier that I picked this case for a specific reason, and this is it. Yeah, that's an optical DVD drive. The Fractal Pop Air Mini is the only micro ATX case I own that still supports a 5 1/4 optical drive. And why go with what's probably ancient tech to most of you? Well, I've got some crazy ideas about resurrecting old abandoned Linux distros that I have archived on physical media. Will I use it much? Probably not, but why not have the option, right? In the end, I spent $858 out of pocket, bringing the total build cost to $947 when you include the price of the case. And it's not bad for a Linux-focused PC with this kind of solid performance, but what kind of performance are we actually getting for that price? Well, we'll get to that in a minute. Before diving into benchmarks, I had to round out the setup with a few peripherals. For the keyboard, I wanted something not huge, but still full keyed, so I went with the Keychron K4 Hot Swap. It came with Gateron red switches, but I'll be swapping those out for a set of Drop Holy Pandas once I actually find them in my storage unit. So far, Bluetooth works okay, but it takes noticeably longer to reconnect after sleep compared to my Keychron on my Mac. And on system reboots, yeah, it's even slower. For a mouse, I'm using the PhotoArc EM11NL ergonomic vertical mouse for everyday productivity, great for long work sessions, but when it's time to game, I can swap over to my Logitech Pro X Superlight. No real compromises there. The display is a 32-inch 1440p 144Hz panel from Scepter. It's actually my old gaming monitor. I just upgraded my main setup to a 32-inch 4K high refresh rate panel, so this one was freed up for this build. It's a solid jack-of-all-trades display, but if gaming isn't a priority, I'd probably go for a higher resolution 4K business class display instead. For sound, I'm using a Bose SoundLink Flex, mainly because it just fits perfectly under the display, nice, compact, and it does the job. Everything else you see up here, the camera, microphone, capture card, it's actually connected to another system, and that's how I'm recording and capturing footage from this build, and you'll see that in action later. With the system built, it was time to get some baseline performance metrics. To do that, I installed Arch Linux. Now, at some point, we'll do a full Arch Linux setup demo, but for now, I'm just using it as my benchmarking baseline. It's a lightweight rolling distro, and more importantly, it's the one I have the most experience with, so I won't go through the installation process here, but I will say it was completely uneventful, which is exactly what you want. No weird hardware issues, everything worked out of the box. For performance testing, I ran my standard benchmark suite, starting with Geekbench 6. Both multi-core and single-core CPU performances were above average for the 5700X3D, while OpenCL compute performance on the RX 7600 XT came in a little below average, both of which were pretty typical results for Arch compared to like a Windows 11 setup. With the Phoronix test suite, all the numbers landed exactly where I expect them to for this system. Of course, there's not much context here yet since there's nothing to compare this data to yet, but as I mentioned in my first video on the channel, all raw test reports are linked in the description below if you want to dive in and even compare your system. For now though, not exactly thrilling stuff. So let's just jump into some gaming and see how this system handles some new and popular titles. Okay, so I installed about a half a dozen games. We're not going to play through all of them, but I'm going to jump into a few just to kind of get an idea of how the system works with gaming performance. And then at the end, I'll definitely come back and do full detailed benchmarkings of at least all the games that I have installed here, and we'll see how they all perform. But let's just go and jump in. Let's start with Baldur's Gate. 1440, we're going to disable our VSync, FSR. Yeah, let's go quality. Let's go overall preset ultra. Let's go ahead and start up some logging here.
I'll go this way.
Looks good. I don't see any artifacting. I have the resolution set down to 1440, 60 hertz on the display. You shouldn't be getting any tearing in the capture, but I'm definitely getting a little bit of tearing on the screen. In particular, feels pretty smooth. Run around for a minute and see what we get. Everything looks pretty good. I'm not seeing any artifacting, any texture problems. Gave me a nasty no major stuttering. Just some screen tearing, but that's of course because of what I have my refresh rate set to. Let's go ahead and yeah, look at that. An average 62 with a 1% of 51.1% of 47. That's pretty good. All right, next we're in Black Myth Wukong. So let's go ahead and kind of give this thing the same 1440p. We're going to turn off VSync, graphics. Now, this is the one you can't turn off FSR upscaling on this at all, but we can turn off frame generation. And then, yeah, I'll take this down. Essentially, 100 should kind of turn it off, but it doesn't really do it. So just take it down to like 50% or whatever this number actually means. If somebody knows what these numbers do, actually drop me a comment below. That's off, and we're going to go with 1440p high. That might be okay for this game. So let's apply the changes. Yeah, see, this is common on this game at all. If you can see as I pan around the character, you can see, especially if you look around his hairline, you can see that kind of artifacting. That's basically from the upscaling, and it's kind of normal with this game, but decent frame rates, feels nice and smooth. This section is actually the same section of the game that is the benchmark. Oh, my light just shut off. Start up the logging here and just take a run through. I don't think I have any enemies to beat up in this section. It's already taken care of, but I'm looking for any areas of texture problems, texture loading errors. Everything looks pretty good. I have ray tracing off. So that water quality, that's just rasterized lighting in here. So, but yeah, this feels pretty good too. Pretty comparable from what I'd expect from this system. So that's essentially, this would be the entire benchmark section if you do the pre-installed benchmark. So let's take a look. Yeah, again, 74 average, just 65, 1%, 60. So that's really smooth gameplay there. I didn't see any stutters, problems, jitters, nothing. So pretty good. All right, really quick, let's just take a look at Cyberpunk 2077 real fast. We're going to do 1440p. Yeah, graphics. Let's go with high. FSR 3. Yeah, let's do FSR 3. Let's go with quality setting. And ray tracing off. Yeah, and go ahead and apply those settings. So far, pretty good. I'm using my ergonomic mouse here, so we might see some mouse lag, some mouse stutter, because this is not a gaming mouse. Yeah. Looking all right. Let's go ahead and start some logging. Again, I'm still seeing some screen tearing on my side, and yeah, a little stuttery, but that's the mouse. Probably not the, but let me switch. I don't know how to play on a controller, but this will get, oh yeah, there we go. Getting the little smoother motion. I have no idea how to play this game on a controller though, so let's just run around.
You got a smoke, huh?
Yeah, that's smoother. Does that jump? Yeah, it does. All right. Again, everything's looking pretty good. All right. Let's go ahead. Let's see where we're at right here. Yeah, average 84, 1% low, 72. That's probably the largest gap between our average and 70. Look at that 1% low or 0.1% low right there at 71%. So yeah, really good. Let's see if we can get some ray tracing into this. Let's go with just high preset and ray traced shadows. See how that works. There we go. That's pretty good. See how that affects things. Let's get out into somewhere where we can actually see some shadows. There we go.
I'm done being a goddamn footsteps.
Oops. Just got hit by a car. I'm dying in the street. Not bad. I can see. Again, yes, that is affecting our 1% lows and our 0.1% lows. And let me see, I think this is where we're going to leave off, just because I know this video is getting really long. But right here, I'll pop up the graph to show the actual benchmarks for all of these games. From what I saw, everything ran really well and probably smoother. That margin between average and 1% lows was super tight on just the 3 games I tested, and I assume it's going to be that way across the board. So again, overall, pretty impressed with what I'm seeing so far from the system running Arch Linux. After running through some live gameplay, it's clear this system delivers exactly the performance I expected: smooth, reliable, and a great balance of power and efficiency for a mid-tier build. Overall, I'm really happy with how the system came together. It's the perfect test bench for showcasing the many Linux distros I'll be exploring here on Lifting Linux. It's built to handle everything from daily workflows to gaming, making it an ideal platform for real-world Linux testing. So guys, if you enjoyed this video, hit that like button, and if you're ready to see how different Linux operating systems perform on this machine, make sure you're subscribed. There's a lot more to come, and I can't wait to take this journey with y'all. See you in the next one.